Good afternoon, everyone. My name is Aslam Tajwala. I'm the VP of Engineering at Cogility Software, where we are building the next generation behavior analytic platform powered by Apache Flink. A little bit of background about the company. We are a startup that specializes in software modeling and analytics. We have helped solve challenging problems in the finance, logistics, law enforcement, and intelligence markets. During our time helping solving these problems gave way to a realization that subject matter experts are the key players in deriving insights from complex behaviors. However, unlike engineers, they lack the programming know-how to be able to quickly verify their hypotheses. To solve this problem, we've created Cogent Platform, which is a declarative, zero-coding visual environment that enables subject matter experts and analysts to quickly capture their hypotheses at thought speed. Our platform uses Apache Kafka for its source of truth and Apache Flink for its processing backbone. Flink has played a tremendous role in powering our analytic engine, and I would like to take a moment to thank the Flink community, especially the contributors, for creating such a powerful streaming framework. I'm now going to tell you two stories that exemplify the use of our platform, and after I present them, we'll go over why they're significant and how we solve it with our platform. Our first story takes place in a city where a violent crime occurs in a neighborhood. Law enforcement arrives at the crime scene. They apprehend the subject. They also collect information such as contact numbers, names, addresses of all the parties involved, including the witness and the victim. The subject gets taken to a county prison where they get booked and put behind bars. All the information collected is now entered into an RMS system, which is basically your public safety database. A few weeks go by, and the inmate and the prison makes a few calls. One of these calls happens to be to the phone number of the witness of the incident they were connected to. Our system detects this behavior and notifies the sheriff's office, who later intervenes and looks at the call transcript for a possible witness tampering or any foul play. Our next story takes place in the middle of the ocean, where a container ship carrying cargo is making its way to its destination port. One of the containers is concealing illegal drug payload within it. The ship makes multiple stops at different ports before arriving at its final destination. At one of these ports, the container carrying the illegal payload switches ships. This, by the way, is a very common practice to obfuscate the origin of a container out in the real world. In addition, both these ships are now headed to the same destination port within very short and similar arrival times, which makes the whole container movement all the more suspicious. Again, our system detects that behavior, notifies the port authorities, who later inspect and confiscate the container. So let me ask you, what do these two stories have in common? I think it'd be fair to say that they're both looking for a sequence of events or patterns or behaviors, if you will, that are looking for these patterns from vast amount of data, sequences or events that can come out of or in sequence. It's kind of like looking for a needle in a haystack. They both require domain knowledge expertise to know what to look for. As an engineers, we will not be able to try to figure out the behavior just from first principles. Only a subject matter expert or an analyst who has spent many years in that field would know exactly what to look for. They both require real-time results. The gap between event time and the time at which the system detects the behavior has to be very narrow. It could mean the difference between life and death in certain scenarios. So real-time becomes absolutely crucial. They both take place in environments where there is constant flux. New variables get introduced and removed from the system all the time. So the ability to be able to quickly change your hypotheses to match your new environment becomes all the more critical. And last but not least, both of these were use cases that we help solve for our customers using our platform. Before we get into how we did that, I would like to give you a very high-level overview of our process and the architecture. So Cogility's Cogent platform begins with the analysts in mind. They have the knowledge of threats, risks, and opportunities, what abstractions make sense, what behavior profiles make sense. All of this is translated into an authoring visual environment which enables them to capture what set of data, what observables, what triggers imply a certain outcome. This then gets converted into a continuous streaming analytic with the help of Flink, which processes high volume, high velocity data along multiple data sources. The result of this analytic at the top level is actionable intelligence. This entire process is iterative. The analyst starts with a model, and they try to hypothesize what they're looking for and validate the results and keep fine-tuning the model as they come across new information. This is a very basic top-down, bottom-up architecture of our overview of an architecture. At the bottom, you have your raw event data coming in. It could be IoT data, social media data, or application data. So in our case, it would be, for the witness tampering scenario, it would be the public safety data or any jail call records that come into the system. For our illegal shipment, it would be journey, port, vessel, ship-related data. All the data comes into Kafka, which acts as a data bus. Each of the event is represented as a topic in our platform. Above that, you have the analyst who's using our authoring environment to create something that's called as a template. I'll get into more details about what a template looks like in the next slide, but for now, imagine a template is a blueprint of what pattern or behavior you're trying to look for in your own data. Once an analyst creates that with our authoring environment, with a click of a button, they deploy that to our runtime, which runs alongside Flink. Our runtime translates the template, which is essentially a JSON file, into data streams running on Flink using the data stream API. At this point, the data streams start taking in data from Kafka and start producing results. These results are sent back to Kafka. Again, at this point, you could choose to consume that result directly with your BI tool or any of your applications within your infrastructure, or you could use our decision support dashboard, which is essentially our solution to analyze the results of our analytic. There's another very important aspect here. While the results produced are written to Kafka, the results here could now be the input to a different template used by another template looking for another specific kind of a database. So in effect, what you're trying to do is you're trying to capture smaller patterns and use the results to capture a larger pattern. I'll get into more of that details very soon. So here's an example of a template. I've used the witness tampering scenario as the example here. Our authoring environment uses a declarative notation, which means that you tell the system what to look for, but not how to look for it. It has a few notations. The ovals represent data sources. In our case, that would be Kafka topics. The lines represent constraints. They define the relationship between the fields of different data sources. A group, the big box surrounding them, indicates that all the inputs and all the constraints must match in order to produce, they must satisfy in order to produce a match. The outcome finally is the result of your template, which could be another event type that gets written into a Kafka topic. So back to my earlier comment about reusing the output of one template as an input to another, this is where you would start publishing out the data for your template, and they could hypothetically be another template that uses the output of this result to capture an even larger data pattern. And in effect, you're looking at a hierarchical complex event processing at play here. So now that we have some knowledge about the semantics, let's take a look at what this template is trying to achieve here. You have 5 different data sources: incidents carrying incident records, booking carrying booking records, and so on and so forth. Jail call is essentially all the calls made from the prison outside to anybody for that matter. And in effect, what this template is trying to say is that it's looking for a set of events where it's looking to flag a single call made by an inmate whose outgoing number matches to the telephone number of the witness that was involved in that same incident. It's pretty cool, right? So having this knowledge, let's take a look at how we see this in a demonstration environment. I'm going to use a live demonstration of our second scenario, which is the illegal shipment scenario for, okay, let's take a look at that. So in our authoring environment, there are basically 2 types: event and template types. An event type is essentially the object definition of your data source. So it has all the fields and the data types for those fields. You could create these manually by hand, or you could perform what we call is a schema discovery. Here, you essentially point your the Kafka broker you want to talk to and perform a schema discovery, which is going to go fetch all the data from your Kafka topics and create an event object definition for you right off the bat. It's a very nifty way to kind of create events very quickly without entering them manually. Once you have all your data sources defined, the next thing you're going to do is create templates. I've already pre-populated the environment with 3 templates that satisfy the illegal shipment scenario. Before we take a look at what these templates look like, I'm going to do something called as a viewing the template hierarchy. Essentially, what this does is it gives you a very high-level tree view of how your templates are connected. So let's start with the first template, which is a container risk. What this template is trying to achieve is it's trying to calculate a score, an overall score for your container, depending on what goods it's carrying and what port your container left from. Transshipment, on the other hand, is looking for any transfer of containers between 2 vessels or 2 ships here. Finally, suspicious cargo is taking account into both the results from container risk and transshipment, in addition to figuring out if both of these vessels are arriving at the same destination at the same time. Without getting into too many details of the template, I'm going to deploy these and show you how that job graph looks on Flink. So I'm going to select a deployment target, which is basically a configuration of your Flink and Kafka IP addresses and ports. I'm going to pick all the 3 templates to be deployed. So at this point, again, our runtime is translating the JSON file of this template into data streams. Let's take a look at what the job graph looks like. So as you can see that all your constraints are then computed as subroutines into this huge job graph that was created without really writing any code. So this is pretty cool, because now we allow somebody who's not familiar with Flink or any of the lower internal programming of a streaming framework, but just by conceptually hypothesizing what they're looking for in our visual environment, they're able to detect those patterns or behaviors from that data. But we don't stop here. While you could use the results of our analytic directly in your BI tool, we also give an array of add-ons or dashboards for the analysts, which are very powerful tools for an analyst's toolbox. These maximize the effectiveness of our analytic. The first one being event drill down. Basically, this gives you the ability to see the provenance of all your data within your hypothesis. Link analysis gives you the ability to view relationships between different entities and their linkages. Entity tracking allows you to track an entity along your hypothesis and bubble up all the way to the top of your hierarchy. And risk analysis enables you to create a risk model based on your template to calculate an overall risk score. In closing, Cogility's Cogent platform makes it very easy to capture behaviors which would otherwise be very difficult to capture. We do this using Flink, which enables us to create stateful computational hierarchy with ease. It's geared and built towards analysts, although anybody with little training could be up to speed and be running to use it. It's zero coding, which means no engineer is involved in translating what the analyst is trying to input into the system, which means that there's faster time to market with very little errors. We have sandboxes available for you to play with to better understand our platform. We also have AMIs available where you can try to find or detect behaviors from your own data in your platform. Although the conference is ending, we are still available in the Olympic boardroom on the 25th floor of this building, or you could always find us in any of these online handles. We'd love to understand your problems with the behavior you're trying to find out in your data and work with you on that. Thank you very much for your time, and I hope you have a great rest of the day.
Is it? Yeah, it is.
Got to talk louder. Yeah. So thanks for the talk. I have a few questions. One is, do you have any problems with the job with a graph that huge? I haven't seen something that massive before, and I was just wondering if you have any problems with the state size or restoring state. And secondly, with this sensitive data that you're handling, do you have any obfuscation when you're storing to state, or do you have to worry about that at all?
So I'll answer your second question first. Because we just provide you the mechanisms to use the ability to capture behavior from the data, we don't really host your data for you. So it's not a SaaS application at the moment. So all of our customers who use this have their own deployment. So they have their own Kafka data sources and their own Flink clusters, and we don't really manage them. But we do give them, so we fit right in the middle where they can just point to any Kafka or any Flink cluster, and we'll be able to do the computation for them. And to your earlier question, we haven't had any issues so far with the big job graph, because most of our customers either have very short-lived data, so they're not maintaining state over a very long period. And in certain cases where that is the case, we have just larger clusters to match that.
Does your tool provide the ability to emit the matches, or when the analyst is building that graph, to see what the results of their of their graph is going to be, and are they able to do any sort of iterative tuning over what they're seeing?
So the decision support dashboards is exactly where an analyst could use those dashboards and add-ons to view the results of the analytics. So you can essentially point at any point in your event hierarchy, and it will be able to give you what that state of that event was at that point, and give you the ability to kind of drill down all the way to the bottom of the first event that triggered that entire tree or branch. So yeah, there are many different facets and ways of viewing that data and try to correlate that. And sorry, your second question was?
About iterative tuning. So if you have an analyst that designs a use case that they think is going to be useful, and then they run it and they see, oh, there's a bunch of things that I didn't think of ahead of time. How do they go and do iterative tuning? Can they add whitelists or exclude ports or exclude containers that they know or find?
Sure. So at the moment, what we would do is we would allow them to redeploy again on a different cluster, and they would replay the data depending on how far they want to go, and re-implement or recapture the new template that way. But we are working on our next version where we can give them hot deploy, where they can change a template on the fly, and it will save the state and version it at that point, and then redeploy with the new state.
Thank you.
You're welcome.
We've run out of time for now. Thank you for Aslam for the great talk and the very impressive work.
Thank you.
Thank you.